All right. Okay, we're going to talk about this girl on a swing. To do that, you go two places to the left. So this would be 2 meters. This would be 0.8 meters. Okay. What's her maximum speed? Well, we'll draw a picture again. I like pictures. Here she is at the top. She's going to swing down to the bottom, and there she is at the bottom. Her height right here is 2 meters. We just said that. And her height here at the bottom is going to be 0.8 meters. What's her maximum speed? Well, the question is, where does that maximum speed occur? Well, it occurs right here. Okay, so up here at the top, this is going to be the initial energy state. This will be the final energy state down here at the bottom. All right. So once again, initial energy equals final energy, and we ask ourselves what energy forms are present during those times. So there's that. What energy forms are present? Well, at the top up here, it's all potential energy. She's not moving. She's got a whole bunch of potential energy due to the fact that she's 2 meters above the ground. P-O-T, potential. At the bottom, she's moving, so she definitely has some kinetic energy, but notice that she's still off the ground somewhat. She's not like our Tarzan in the previous problem where he was on the ground. If you're on the ground, you have no kinetic energy. She's still off the ground, so if the strings were cut at this point, she would fall to the ground. They likely won't happen, but if they were cut, she would fall. She's got some potential energy. So down here at this point, we've got some kinetic, and we also have some potential. Kinetic and potential energy. That's the final energy state. All right, so initial energy, we'll write our equations. Potential energy is mgh. Final energy, we have some mgh, and we have mostly 1/2 mv squared, but we got to take both into account. Now, in the previous Tarzan problem, we could cancel out the mass. We could do that in this one too, but it's a little bit more complicated because you have to factor mass out of each side. M times GH, factor mass out of here, you're left with a GH. Factor mass out of this, you're left with 1/2 V squared. If you don't want to do that, go ahead and plug mass into all of this and calculate it as it is, and you should get exactly the same answer. This goes away, this goes away. So we're left with GH equals GH plus 1/2 V squared. Notice that this H is not the same as this H because this is the initial height. This is the final height. So we'll plug stuff in. 9.8 times 2 equals 9.8. The final height is 0.8 meters plus 1/2 V squared. And I'll come up here with the next steps. (9.8) times 2, if you do that, you'll get 19.6. And that equals 7.84 plus 1/2 V squared. Subtract 7.84 from both sides, and you'll end up with 11.76 equals 1/2 V squared. To get rid of a 1/2, we can multiply both sides by 2. And after that, we get 23.5, and that equals V squared. Take the square root of that, and V will equal 4.85 meters per second.